Finally, nuclear fusion records that's been there for 24 years has been broken. That's very, very big news for nuclear fusion community, and that has a very strong implication that we may be able to really do the break even of any nuclear fusion in the next 3 years. So that's what we are going to talk about. If you would like to receive more technology reviews, videos like this, don't forget to subscribe. So it's not even broken the records. It's even double. It has double the records. It's pretty cool, and this record is like never been broken since 1997. It's very weird for me why this record just been there for so long. Usually in the science, this kind of records will be like a broken once every year, at least every year, right? So what we are talking about is the Joint European Tourist JET. Is a short form JET. It's near Oxford, UK, and it's a nuclear fusion lab. It's a very big machine, a very big lab. They built this kind of very expensive lab. It's a very expensive lab, and they just use a certain way of doing nuclear fusion. It's a very engineering way to do that. Use magnetic fields to contain plasma, and then the energy they can generate is double amount of the previous records. And why nuclear fusion really matters, why we're talking about that, why we're so excited, it's because if we can really do nuclear fusion in the really efficient way, we can have limitless clean energy. It's totally clean. It doesn't have radiations, anything. It doesn't have like a waste problem, and you just need a small, very tiny amount of your ingredient, and you can generate the power that can power through the earth for years. Okay, so this jet really did well, and just let me explain how nuclear fusion works a little bit, so you won't be that confused. Nuclear fusion, it's if you heard of E equals to mc squared. It's the way to transfer mass into energy. So doing the nuclear fusion reactions, there's some mass will be missing, and they will be converted to energy. And how they do that? They use first of all, you need to heat up the environment to very hot. It's like the temperature is 10 times of the sun, and you need to have a very high pressure. But it's very hard to create high pressure environment. The high pressure I'm talking about is really high. That's very hard. But that's easier for scientists to do hot, superheated environment. So they kind of heated hydrogen isotopes, which is the hydrogen. They has one more nuclear. Okay, so they heated the gas of hydrogen, which we call plasma, and then this plasma will fuse with helium. When the isotopes fuse with helium, the energy will be converted to the mass will be converted to energy. So that's how it works, in simple way. Okay, so now you know this is how they do, and it's much more much more clean than nuclear fission, and much more efficient than that. And what's really exciting about is in 3 years, another lab is called ITER, which costs $22 billion is going to be operated. So in 3 years, we may be able to do the same experiment, the same mechanism, the same engineering architecture as JET, but it's much larger, and the scientists predict we will be able to at least do like break even, or even we will have more energy than we put in. Yeah, because so far, why we couldn't like commercialize this thing is because we can do nuclear fusion, yes, but we are not able to generate more energy than the energy we put in. So they just won't be worth it. It's just not even break even. Okay, so in the next 3 years, we may be able to really do get a positive energy out of the whole nuclear fusion reaction, and they'll be very, very big, because if we can do that, and just that means we may be able to really commercialize this technology, and there'll be nuclear fusion reactors everywhere. Then we will have clean energy. One thing we probably know is we can have like a break even or a slightly positive energy ratio. We still need to wait maybe at least a decade for this technology to really commercialize. No one can predict that, but I hope we can do this faster, because the climate change crisis is really, really here, and those clean energies alternatives just not really going that well, like solar, wind energies. It's still pretty minor compared to the energy that we consume. We really need a game changer here, so that we can transition to clean energy much faster. So that's why I'm so excited, and I think you should be excited as well. That's the technology review today. If you really like this video, definitely give a like or leave some comments in the comment section below, and subscribe. Your subscription really means a lot to me. They give me a lot more motivation to make more videos like this. Other than that, I will see you next time.